Alright, so 7.3 is solving exponential equations. Now, we know about exponential equations, right? That's in the form of y equals c to the power of x, and we talked about the parameters in 7.2 as well. If we're asked to solve that, then what that means is we are given this, let's say c is 2, and if we're given this and I say, okay, well, I've got 64 here, and I want to know what the x is. All right. Now you can look at that, and you should know what that x value is right away. That shouldn't be a big deal to you, but because this is an easy one. But they're going to get tougher, and how do we do that? So we're going to talk about two different ways to solve exponential equations. One is algebraically. I'm going to show you one method to do that, and then of course graphically. So that's what we're looking at for this section. All right. So what is the answer for x here? If we're to solve for x, now we can't just divide by 2, right? Because 2 is not being multiplied by x, so we can't just solve it like it's 64 equals 2 times x. It's 2 to the power of x, right? So can any of you look at this equation right now and know what x is? 6. Okay, very good. Can you tell us how you did that? Or what thought process did you use? Well, how did you come up with 6? Did you just trial and error it? Did you use your calculator? What did you do? So you knew 2 to the power of 4 was, and you can't remember now, 16. Okay, so you knew 2 to the power of 4 was 16. Okay, and how did that help you? Because I don't see 16 in here anywhere. Okay, so then you thought 2 to the power of 5 was 32, and then you know that you're doubling every time we increase this exponent by 1. So then it's like 2 to 6 is 64. Boom, x is 6. Okay, very good. Now I want to point out what you did here without even knowing it. You took 64 and you said, that is 2 to the power of what? Right? That's what you did. You said, I know 64 is the power of 2, so it's 2 to the power of what? And then you kind of figured it out, 4 is 16, okay, well then 32, 64, okay, it's 6. So that's the beginning point of the algebraic method I'm going to talk to you about. So let's write this again. 64 equals 2 to the power of x. And the formal sort of explanation of how to do this is, on this side here you have a power, right? And x is in the exponent position. If you can write the number on the other side of the equation with the same base as this power, with the same base, that means that if the two sides have the same base, then the exponents will also equal each other. So this algebraic method, and I put a little star beside them because, again, this is just one method. I'm going to teach you another method next chapter. But this is one method. Write, okay, here's your little note here. Write both sides of the equation with the same base. Okay, the same base. So that 64 becomes, let's try and figure out what power a base 2 it is. Right? This is what we're going for. So if we can write them with the same power of 2 here, then I know that these are also going to be equal to each other. See that? And that's really what you did to solve this kind of simple one. And so you said, I know that's 6. So guess what? When they have the same base, it's almost like you can eliminate that constant part, and then 6 becomes the same as this unknown here. And so 6 equals x. That's your answer. X equals 6. Okay? So it's really easy, actually. You try and write both sides with the same base. Now, this isn't going to happen every time, but for in this section, we're going to be able to do that. So here's another one, okay? 4 to the power of 2x equals 8 to the power of, what is it? X plus 1, okay? So this is an example in your book, okay? You can follow along if you want, but if you look at this right here, and it really helps if there's just sort of one term on each side of the equation, right? So it's kind of, a little bit on the simpler side, right, when we're learning this. But can you write 4 and 8 with the same base? 2, yeah. Okay, so now watch how we're going to change this. So 4, you said, is going to be 2, and it's actually 2 squared, right? So that's actually 2 squared to the power of 2x. 8 is 2 cubed. And so that actually becomes 2 cubed to the power of x plus 1. Everyone see that? That's our first step. And from there, we kind of, when we eliminate these brackets, we want to use our exponent laws. This becomes 2 to the power of what? 4x, that's right, because you multiply these two together. Okay, so you do have to simplify, get rid of these brackets and everything. This over here becomes 2 to the power of what? 3x plus 3. Very good. So when you get to this point, the bases are the same, the bases are equal, so that means that the exponents must also be equal to each other. So you can now just go to this step where it's like, hey, now I have x out of the exponent position, I'm just writing it as a regular old factor in the terms here. See that? Okay, does everyone see how I went from this step here down to this step here? All right. Now this is easy. Now we just do regular old algebra stuff. And this is x equals 3. Let's check that and see if we did this right. So 4 to the power of 2 times 3 should equal 8 to the power of 3 plus 1. So that's 4 to the power of 6 should equal 8 to the power of 4. Now, if you don't know those offhand, that's fine. Get out your calculator and you can just check that, right? So we'll turn it on here. Oops, exit, quit. So that's 4 to the power of 6 and 8 to the power of 4. There you go. They're the same. So we've checked it and it looks good. So x equals 3. Got it? All right, so when we have an equation like this where the unknown value is in the exponent, I should just make a special note of this, that this is called an exponential equation. Okay, so we've talked about exponential functions, that's y equals, but when we have an equation where the unknown value is in the exponent position, that's just called an exponential equation. Okay, so that will be referred to many times. All right, I'm going to give you one to do on your own. Okay, so just there's a quick example. So just copy this down and take a minute to do this. 9 to the power of 4x equals 27 times x to the minus 1. Okay, so just take a moment to give that one a try. All right, so assuming you all had a chance to take a look at it. Now, if we take a look at 9 and 27, can they be written with the same base? Yes, 3, right? So 9 is 3 squared. 27 is 3 cubed. If you multiply, 2 times 4 is 8x, 3x minus 3 here. You let those two equal each other, and you get x equals negative 3 over 5. Anybody else get that? Yes? No? Yes? So if we do a check here, right, you plug negative 3 over 5 in there, and you get these two right here. Plug it into your calculator. Like that, you should end up with the same number if you've done it correctly. So there's your check as well. Questions? No questions? All right. The second and final way for this lesson here, algebraically we've just covered, graphically now. And graphically, pretty straightforward, just like we've done when we've solved graphically for any other equations. What you want to do is you want to graph the corresponding equation on this side, so y equals this, and y equals this over here, and then find their intersection point. So you'll all need a graphing calculator, so you can come up and grab one, and let's go through that and input the corresponding functions into the graphing calculator. So using graphing technology here, TI-83 is what we have. You go to your y equals button right here, and this is the screen that pops up, right? And so y equals 9 to the power of 4x. I'm going to put that into one of those, and then y equals 27 to the power of x minus 1. If you graph them both and you hit graph, you're going to see this. Now it's tough to tell because this is a standard window, but the one graph here, the 27, is right up pretty close to the y-axis, and this is the I think the 9 to the power up. So we can't really see where the intersection point is here, but we're going to have to zoom in, and we're going to have to see if we can see that. So if you don't know, if you want to fiddle with the zoom, with the window functions, you can always hit zoom in. That's 2, and then hit enter, and see if that clears things up for you. And, okay. So there's the 2, still can't really see, so why don't you zoom in again, hit 2, and then see what happens here. Okay, we've got that, and we've got this. So it looks like we might have an intersection point over here somewhere. Okay, is everybody with me or no? Well, I just zoomed in twice. Okay, now I don't know if the intersection point is actually on the screen. Now here what you can do is go to your window and say, okay, look at where's the x min here is negative 0.6. So you probably could change that to negative 0.9 or something. And graph that again and see if we can see that intersection point a little more clearly. I don't know. Yeah. You might want to change your y range as well so you can see this a little bit better. So we go to window there, let's go to the y. There's the minimum, let's go, well, negative 0.01. We don't need much below the x-axis. And then let's make this a little smaller too. So instead of 0.625, why don't we change that to 0.235? Let's see if that helps. Let's see if we can see this a little clearer. Maybe a little bit more. I think we can probably go ahead and try and find intersection point now. So do you remember how to do that in the calculator? Second function, trace to get to the calculate screen. Option 5. Now it's going to say first curve, and if you don't know where the cursor is, you can always kind of shoot it over there and oh, maybe it's the other way, I don't know where to go. Well, it actually doesn't matter too much because, oh, there it is. You can see it listed up here on the screen. So that's first curve, yep. And as long as it pops to the second one, yep. Hit enter. Now guess, yes. And we'll see if the intersection point is there. Let's see. Okay. The intersection point is at negative 0.6. Okay, look at that. That is this value right here. That's negative 0.6. And the y value should be this right here. And recall that when we look at that number, 0.005126, when we evaluated them, guess what we got? 0.005126. So that is the method number 2. That's graphically. So you just basically graph both corresponding functions. So whatever's on this side, you graph it. Then you graph whatever's on this side simultaneously. And you find out where they intersect. Get the calculator to do all the grunt work for you. And there you go. You can see on your screen there. Again, I'll do it one more time. 5, enter, enter, enter. Because it's on the screen, there's only one intersection point. There it is. So that's your x value, that's the solving. Negative 0.6, or negative 3/5. So let's just run over one of the questions here from your assignment. This is the question, and the question says, write this as a single power of 4. So you have two pieces here, this root 16 times times the cube root of 64 squared. So if you write them as a power of 4, this is 4 squared. That's what 16 is. So just write that. And then this is 64 is 4 to the power of 3, right? So that's the big thing. Get the numbers that you see in there with the same power. Now, what is 4 squared and the square root of that? That's 4 to the power of 2 over 2, isn't it? Okay. Right? If they cancel each other out, that's 4 to the power of 1, okay? I'll do that next. I'll show that next. Now this one here, this is a bit tricky. What is this as a power of 4 here? What do I do with all these numbers? Okay, the 3 and the 3 could cancel out. Yeah, if we did it the same as I did over here, what would actually be the exponent, considering all these numbers? 3 times 2 would go in the numerator, and this 3 would be in the denominator. Now, if you think about it your way, the 3 and the 3 cancel out, so what's left over? Just the squared. Is not 6 over 3 actually just 2? Wow. So that's 4 times 4 squared. As a single power of 4, what's the exponent? 3. Because this is a 1, and you add exponents like bases. You multiply it. 4 to the power of 3. Everybody see that? Okay? Hopefully you're able to understand what it just did there. That's something that you're going to need to be able to do in order to solve algebraically. Okay. I'll pause to give you your assignment, let you get working, and let me know if you have any questions while you work. Alright, so here's your assignment for this section here, 7.3. Do 1, 2, 3, 4, 5, 6, and 7, A, C, and 8. Okay? You want to get awake? Yeah. Okay, go get a drink. I'd like to get awake too.